Hello everyone. In this video, I will explain more examples of context-free grammar, how to write the context-free grammars. We will see more examples. Now read this question. It says that write context-free grammar for the given language. Now see the language. It says that a raised to the power I, b raised to the power j, c raised to the power k, where I and j are same, that is j is equal to I, or j is equal to k. That is, we can clearly write this as the language is made up of either L1 or L2, where L1 is having this pattern, number of A and number of B's are same. That is, I can write, if J is equal to I can write this as I, and C is independent in this case. And the another language, L2, where number of number of B's are equal to number of C's, that is J is equal to K. So I can write this as A raised to the power I, B raised to the power J, and C raised to the power J. Now we will write the grammar for this and grammar for this. See the grammar for L1. What I can take this as, we know that number of A's and number of B's has to be same. Take some variable x1. That will make number of A's and number of B's same. Whenever A is there, B has to be there, or null. Why I am putting this as null? Because we can clearly see that this I can have the smallest value, which is equal to 0. So I can put this as null. And then this C, for this C, x2, take one more variable x2, C x2, that is any number of C's will be generated with this variable x2, and again null, as we know that this x2 is nothing else but k. K has a value, that is smallest value of k is 0. So I have this grammar for language L1. For example, I can see that if I generate this x1, from x1 I can have ax1 b. Again call this x1, replace this x1 by ax1 b, and so on, and replace this x1 by null. I'll get, in this case, in this example, I'll get a square b square, that is same number of a's and b's. And then for again what we need to do, we have to generate x2. x2 can generate any number of c. Suppose I call this thrice. Eventually replace this x2 with null, so I get c raised to the power 3. Now we need to combine these two, so I have to write one more expression. Suppose I call this S1. S1 is the concatenation of x1 followed by x2. So we have the grammar, the context-free grammar for the language L1, where number of the pattern is all A's followed by all B's followed by all C's, where number of A's and B's are same. So this is the grammar for it. Now let me write the grammar for language L2, where it says that number of A's and number of B's, number of A's is independent of number of B's and C's. Number of B's and C's are same in this case. So again we need to write, take some variable, say y1. This is for a, y1, or null because we know that this I can go up to what smallest value of I, we have 0. So therefore I can replace this value with null. Now take one more variable y2. that will make sure whenever the B is there, C has to be there so that we can have the equal number of B and C. So I will write this as B, Y2, C. Eventually, we have the smallest value of j is equal to 0, so I can replace this y2 with a null. So now, obviously, we need one more variable s2 that will combine the combination of y1, that is concatenation of y1 variable, and then followed by y2. So this is the grammar for L2. We can clearly see, take some example. Suppose I want to generate A3, B2, C2. So I can do it with derivation, suppose y1, or start from s. s2 is replaced by y1, y2. Leftmost, I am using leftmost derivation. Take this y1, replace with a y1, y2. Again, since we need 3 a's, I'll keep calling this y1, a y1. Again, one more time. Now replace the y1 with null. So I'll get 3 a's followed by y2. Now there is only one variable for the replacement. For b and c, we need 2 b's and followed by 2 c's. So I'll keep calling this y2 is replaced by by2 c. Now replace this y2 by this derivation, that is this grammar. y2 is replaced by by2 c. So a3 followed by by2 c. Again, one more time, this y2 will be replaced by so we have got this 2 b's and 2 c's. So I will finally replace this y2 with null. So I'll get 3 i's, 3 a's followed by 2 b's and then followed by 2 c's. So this particular thing is center type. Now we have the language. The main language was either L1 or L2. That is, L1 is where number of A's and B's are equal, and L2 is where number of B and C are equal. So now we will combine these two into one single grammar. We have already written the grammar, context-free grammar for L1 and L2. Just combine the two. So we will have the main grammar, that is the language S. The grammar will start with S, symbol as the start symbol S will be S1 or S2. What is S1? S1 is the start symbol of L1. See this? S1 is the start symbol of L1 and S2 is the start symbol of language L2, and we know the main language L is nothing else but either L1 or L2. So the grammar is S, either S1 or S2. Now combine all these grammar which we have written above. So I will just copy them here. S1 is nothing else but X1 followed by X2. X1 is nothing else but A, X1, B or null, and X2 is nothing else but C, X2 or null. Also copy the one written for the language L2, that is S2. S2 is nothing else but Y1, Y2, where Y1 is A, Y1 or null, and Y2 is B, Y2, C or null. So this is the context-free grammar for the language. See the language one more time. This was the language. A raised to the power I, B raised to the power J, C raised to the power K, where number of J is equal to number of I, or number of J is equal to number of, that is J is equal to K. it means that number of, if I see j is equal to I, it means number of a's and number of b's are same. Or if I see j is equal to k, it means b and c's are same, number of b and number of c's are same. So this was the context-free grammar, final context-free grammar for the given language is this. Now we'll check the next example. See this question, it says that language L is a raised to the power I, b raised to the power j, c raised to the power k, where I is equal to j or I is equal to k. We need to write a context-free grammar for this language. For some I, j and k greater than equal to 0. So it is clearly mentioned that L is nothing else but L1 or L2. Where language L1 is equal to a raised to the power I, b raised to the power I, since in this case I is equal to j. So instead of writing j, I am writing it I, and c raised to the power k. And the second language L2 is nothing else but a raised to the power I, b raised to the power j, and c raised to the power I, because in this case I is equal to k. So it means that language L is L1 or L2. L1 is given as a raised to the power I, b raised to the power I, since we need to have a and b same number of a's and same number of with same number of b's, and then followed by c raised to the power k. And in L2 we have a raised to the power I, b raised to the power j, because number of a's and number of b's are independent, but number of c's has to be equal to number of a's. So in this case what I will do, I will write the grammar for both of these languages. So I will start with language L1. I will write this start symbol S1 has production rule x1 some variable x1 and x2, where x1 is nothing else but it will make a balance between a and b, a x1 b, or null. Why null? Because we can clearly see that this I is greater than or equal to 0. It means the smallest value of I is equal to 0. Now what is x2? x2 is any number of c's. So this is c x2, or null, as this k, the smallest value of k is 0. So therefore this is the grammar for language L1, and for language L2 we have the grammar. We will have the start symbol S2 is making a balance between A and C. A S2 C, or take one more variable B, and this B is nothing else but any number of small b, or null. Why null? Because this j has smallest value equal to 0. And remember that this s variable s2 can be replaced by b. That is, we can have only b's. If I is equal to 0, then we will have a raised to the power 0, b raised to the power j, c raised to the power 0. It means that these two values become null. So we can have only b's. If we have only b's, so therefore s2 can be replaced by this capital B, that is this variable, and this variable is replaced by B, capital B, or null. Finally, eventually I have to write this grammar for language L. So we'll combine these two languages, and the grammars of L1 and L2 will be combined into final grammar, that is S. S is nothing else but the start symbol of language 1 or start symbol of language 2, and then we all know what is S1. S1 is x1, x2. What is x1? x1 is a x1b, or null. What is x2? Just copy it from the previous lines, cx2 or null, and we know what is s2. S2 is A, S2, C, or B. What is B? Is small b, capital B, or null. So this is the context-free grammar for the language. I hope this is clear to all of you. Thank you for watching the video. Please do write your comments.